This video we are going to discuss question based on centroid, incentre, orthocentre and circumcentre of triangle. Now all this point we have discussed in detail in coordinate geometry. It's just that in this we are going to introduce vectors in there. Okay. So let's start with case number 1, that is centroid of triangle. Okay. Now when we talk of centroid of a triangle, what it means, centroid, if you know, is intersecting point of median. So the very first thought is centroid is intersecting point of median. Okay. Now diagrammatically, if you see, the medians are basically the segment drawn from a vertex which divides the opposite side into two equal parts. Okay. So I'm here just drawing two medians because I just want to show intersection of the medians. So if I take a triangle ABC, D is a midpoint of BC and E is the midpoint of AC. And this intersecting point is the centroid, and the notation for centroid is G. Now, other than this, one more thing we should know here is your centroid divides median internally in the ratio 2:1. Okay, so I repeat the statement one more time. Centroid, let's write centroid divides median internally in the ratio 2:1. Okay, so here what we find is a median AD, your G divides AD in the ratio 2:1. Okay, so we can apply section formula here to get the result. Is that clear? Now when we apply the formula, we get centroid formula, and that goes like this: centroid formula. I'm not giving the proof of it. We directly remember the centroid formula is A bar plus B bar plus C bar upon 3. If you can recollect, in coordinate geometry we used to say sum by 3. Okay, so the centroid formula is sum by 3. Fine. So we'll be, whenever in a question we find centroid, we think of this result. Okay, that is G bar is equal to A bar plus B bar plus C bar upon 3, that is sum by 3. Okay, so make it very clear, this is the formula we should know for centroid, sum by 3. Okay, now let's take the second case, case number 2. Okay, where we discuss in center of triangle. Now when I say in center, it is nothing but in center is intersecting point of angle bisector of triangle. Okay, now here the keyword, if you see, is angle bisector. Okay, so if you just if I just show you in the diagram, is it not, it means something like this. We have a triangle ABC, let us bisect the angles. Okay, I bisect the angle, here also I bisect the angle. I just show two angle bisector because I want to show point of intersection, and this is in center I. Now please don't mix up, your centroid divides the opposite side into two equal part. Okay, but in center divides the angle. So both are different things. Okay, so make it very clear, you don't mix up the median and angle bisector. Okay, now with this, please remember we had one property for angle bisector, if you can recall, which says BD upon DC is equal to AB upon AC. We have seen this in the concept of angle bisector videos. Okay, so just keep this property in your mind. Okay, and one more thing which is not that important, but you should remember, incentre divides. I would show diagrammatically, that will help you in a better way. Okay, now what we do, if you have just seen properties of triangle, we take this side as small a, the side opposite to capital A is small a, side opposite to capital B is small b, and side opposite to capital C is small c. Okay, this is the standard notation which we use. So can I say this BD upon DC is equal to, is it C by B? Okay, so this is the property first of all you should remember. And also I divides angle bisector AD internally in the ratio. Now just see here, here it divides. Now to write the ratio, remember this side which I have, okay, that is A, I'll write it here, okay, and this including side is AI. So let me repeat one more time here. This A will take this ID value, okay, and this would be taken by addition of this two side. Okay, now how we got this result, that is none of our not to be proved here, we just remember it directly. So what I can see here is, when I say AD, if you can imagine the diagram, the side opposite to A is A, so here you should write A, and the remaining is B and C, so we add B and C. So this is the ratio. Matlab, can I say B plus C is to A? Okay, later on in the theorem we'll be proving this particular result. Okay, not that important result for some, but then please remember it. Okay, now if I include all this and solve it by section formula, we get the formula for incentre. Okay, so incentre formula is I cap is equal to A bar plus B bar plus C bar upon A plus B plus C. Okay, now here please remember your A was length BC. Okay, and length matlab magnitude of BC bar. Likewise B, and it is very easy to remember, there is no need of diagram. If I am talking of A, the remaining is BC. So if I am talking of B, the remaining is what? AC. So I say mod of AC bar. And if I talk of C, it is nothing but length of AB, which is nothing but mod of AB bar. Okay, so this is the formula for incentre. Are you getting this? Now see, we are not having the formula of orthocentre and circumcentre in the syllabus, but just for the sake of reference, I am giving it. Okay. So case number 3 is, case 3 is orthocentre. Okay. Now what is orthocentre? I repeat, orthocentre is intersecting point of altitude. Okay, so it is intersecting point of altitude. Fine. So what I find is, in diagrammatic way we have this. Okay, altitude matlab perpendicular. Okay, now, as I said, we are not going in depth of this. Okay, just remember this diagram for your reference. Remember here BD upon DC is equal to, when I say BD, remember it is tan C upon tan B. How do we remember? BD goes to C and DC goes to B. Okay, so this angle you need to remember it. Fine, so this is the ratio, that is one thing you should know. Also fine, this altitude intersecting at point H, this is the notation. Okay, also H divides AD internally in the ratio Okay, now again if you see here, I am having A, D and H. Now A के opposite I'll write tan A. Okay, and what is left out? Tan B and tan C, and you should add them. Okay, that's just like in center. We write this ratio. The only difference is there we talk about side length, here we talk about tan of the angle. Okay, so it is tan B plus tan C is to tan A. Are you getting it? But again, as I said, it is not that important. Just for the sake of understanding, you remember it. Okay, now orthocentre formula. Okay, if I go by section formula for this, we might get h bar is equal to, I get tan A bar, tan B bar plus tan C bar upon tan A plus tan B plus tan C. Okay, so it's just that in place of ABC, we are writing tan A, tan B and tan C. Are you getting this? Okay, so here we got orthocentre formula. Okay. Yep. So here we got orthocentre formula. Okay, fine. Now, okay. So the next thing what we study is the circumcentre. Okay, so case 4, we talk about the circumcentre of the triangle. Circumcentre of triangle. Now when we say circumcentre, circumcentre is intersecting point of perpendicular bisectors of triangle. Okay, so diagrammatically if you see, it is basically this. Okay, so there's a triangle ABC is there. Okay, the midpoint of triangle is D, and if I draw a perpendicular, this is perpendicular bisector of BC. Okay, let's take midpoint of this and let's draw perpendicular. Okay, this is perpendicular bisector of AC. Let's call this as E, and that intersecting point is circumcenter. Okay, now what you should know is it not your D is midpoint of BC? Okay, and here the ratio in which the circumcenter divides perpendicular bisector, okay, the, or I can directly give you the position vector of the circumcenter. It is sine 2a a bar plus sine 2b b bar plus sine 2c c bar. Okay, let me rewrite it here. We have O bar is equal to sine 2a a bar plus sine 2b b bar plus sine 2c c bar. Okay, as I said, it is not so important, so I am not going in detail of this. Okay, so sine 2a, sine 2b, sine 2c. Okay, okay, fine. So this is about circumcenter. So here we come to an end of the 4th results. Okay, which are related to triangle. Okay, it all starts with centroid. If you can recall centroid, for centroid you need to remember sum by 3. Okay, this is the formula you should go for. The next is incentre. Incentre formula is a bar I cap is equal to a bar plus b bar plus c bar upon a plus b plus c. Okay, where a is the length of the side opposite to angle A, that is BC, b is AC and c is AB. Okay, these two formulas we should keep in mind because it is there in the syllabus. But for orthocentre and circumcentre, it is not required to remember the formula. But there is one very important result relating centroid, orthocentre and circumcentre. Okay, important result for JEE. Now that result says the centroid of triangle divides segment joining circumcentre and orthocentre internally in the ratio 1:2. Okay, it is a very important result. Remember, who divides? Centroid divides, segment joining, circumcenter and orthocentre internally in the ratio 1:2. Okay, so if I show this diagrammatically, what I mean is a segment is there. Who divides? Centroid G. Okay, to whom it divides? Circumcenter. Remember, okay, and the notation of circumcenter is O bracket O bar, and orthocentre, the notation is H bracket H bar. Okay, so please remember this is centroid, this is circumcenter, and this is orthocentre in the ratio 1:2. Okay, now this one goes to orthocentre, this 2 goes to circumcenter, and if I apply section formula, I get a result which says G bar is equal to 1 time H bar plus 2 time O bar upon 1 plus 2, and therefore can we say G bar is equal to H bar plus 2 O bar by 3, and that is how we get the relation between circumcenter, orthocentre and centroid. Okay, so with this we come to an end of the introduction of all the formulas related to important points of the triangle. I repeat, 3 things to note here. One is centroid formula, which is sum by 3. Next is incentre formula, which is a bar plus b bar plus c bar upon a plus b plus c, and the relation between centroid and orthocentre, which says that centroid divide segment joining circumcenter and orthocentre internally in the ratio 1:2, and on applying the section formula we get this result. Okay, I repeat here, please don't by heart H and O. In question they will change the name of the points, they can say P, Q, R, S. Okay, so rather than remember who divides, centroid, to whom it divides, circumcenter, orthocentre, in what ratio, 1:2. Remember that statement itself. Okay, so with this we come to an end. The sum based on this will be discussed in the next video.